So I'm going to talk about RISC-V design freedoms and how that relates to verification quality. So a bit of background first about Imperas. Kim mentioned my background with Verisity in the EDA industry. Verisity was instrumental in verification methodology, but others in Imperas also come from EDA. Simon Davidman, the founder and CEO of Imperas, was co-founder of Co-Design Automation, who brought us System Verilog, and other areas, FPGA, processor IP companies. What we saw 14 plus years ago when we started the company was this need for tools and methodologies similar to EDA, but in the software world, based on software simulation. And then 5 years ago, we saw that RISC-V was transitioning from an academic exercise to an industrial community. And we said, okay, well, this looks really good to us because we know how to build processor models, we know how to build tools, and we've done this to support more than 12 different instruction set architectures. So jumping into RISC-V actually was a very natural move for Imperas. Design verification wasn't our first thought. We've been working on tools for software development. However, our customers shouted this at us, that design verification was important, that with RISC-V, processor DV is on the critical path for broad RISC-V adoption. So let me talk a bit about ISAs, past, present, and future, put RISC-V in there, maybe in a bit of context. We've got the 50-year anniversary just a month or two ago of the invention of the microprocessor. The x86 architecture has then dominated effectively the last 40 years in the compute space. And then ARM has dominated the mobile space for, say, the last 20 years, give or take. With RISC-V, RISC-V is poised to dominate the unclaimed markets for the next 20 or 30 or 40 years. And these unclaimed markets could be automotive, IoT, security, AI. These are markets where there isn't a dominant architecture at this point in time, but I think if we come back next year, we come back the year after, we're going to see RISC-V staking a claim to these markets. So how did Intel and ARM come to dominate their market segments? Well, early entry is an obvious thing. But also their products met or exceeded the market requirements and expectations. Their ecosystem was important. These companies built significant ecosystems to help their customers, and they also produced quality products. So can RISC-V duplicate what Intel and ARM did to dominate those unclaimed markets that I was talking about? So let's start and look at what is RISC-V. RISC-V is an instruction set standard. It's an instruction set architecture standard. It's also the ability to customize a processor to meet specific market requirements. What does that give us? Actually, gives us Pushme-Pullyou for those of you that have young children. So RISC-V is a Pushme-Pullyou between compliance and customization. On the one hand, you've got compliance, and compliance to the instruction set architecture, to the ISA, is important for the ecosystem. It allows the ecosystem companies like Imperas to leverage across multiple customers. But customization is also important. Customization allows companies the ability to build a product that is specific for the market that they're targeting. So, back to this question, how did Intel and ARM come to dominate? What can RISC-V do? Well, if we take a look at this, early entry actually is very dependent upon the business, depends upon the market that they're attacking. There isn't a lot of control over that. But in terms of the product meeting or exceeding expectations, that's where the customization of RISC-V comes in, because now companies can build a product that's going to meet or exceed expectations. And then the compliance side of things, and having this architecture, this ISA that's doing things, That's another significant piece of it. So now we have 3 of the conditions. The 4th one is the quality product, and that's where verification comes in. The critical element for RISC-V worldwide domination is product quality, and product quality is RISC-V design verification. So a quality product means a comprehensive DV effort. I mentioned Simon's background with System Verilog, my background in verification. And what we did 20 years ago in the EDA industry was to collaborate with our leading customers and helping those customers to achieve over 90% first silicon success versus the industry average at the time, which was actually a little bit lower than 40%. However, verifying the blocks in an SoC, verifying a full SoC is very different from verifying a processor. Part of it is that Intel and ARM have kept their verification technology in-house. It's basically proprietary. The best known methods are not public. However, what we've seen is that engineers have been leaving these companies and now taking jobs in the RISC-V community in various companies. And Sci-5 and Codasip are actually examples of, in effect, whole teams coming over from Intel or ARM to bring this verification knowledge to the RISC-V community. We've also got processor IP companies, Andes and MIPS are good examples of this, that had their own proprietary architectures in the past and have migrated to RISC-V and so are now bringing the 10, 15, 20 plus years of experience to the RISC-V community. If we take a look at RISC-V, we can see on one axis complexity, on another axis customization. We get these arcs or tiers of increasing verification requirements. Just gives a good visual for how we want to look at the DV problem. But again, processor DV is not SoC DV. There are some commonalities. You still want to use techniques like UVM. You still want to use constrained random test generation, which is now typically called instruction stream generation. You still want to have functional coverage metrics. However, a reference model is going to be needed for DV. That's one of the ways where Imperas comes in. And those advanced processor features, multiple hearts, interrupts, privilege modes, these things make the DV requirements much more demanding. So we can come back to this chart now and look at the low end and say, well, at the low end, a post-simulation trace compare methodology is going to work. At the high end, an asynchronous step and compare methodology is needed. There's a whole spectrum of verification methodologies in between there. At Imperas, we've been working with our customers and partners, working together to develop and publicize the RISC-V DV methodology from low end to high end, working with people that are developing their own RISC-V processors like Nagravision, NSI-Tex, NVIDIA Networking, Silicon Labs, and also working with the processor IP vendors, Andes, Codasib, MIPS, Open Hardware Group, and Sci-5. So I'd like to actually show a video from one of those.
Hello, my name is Koji Adachi, NSI-Tex. I'm a manager of RISC-V core development. NSI-Tex is a subsidiary of Denso, well known in the automotive electronic devices. Over 2 years, NSI-Tex has been developing multiple hard vector RISC-V processor with Imperas. As for this year's news, our first product DR1000C have received the ISO 26262 SUD ready certification. Now, done big deal with one of the most famous automotive MCU vendors. We have already started a new core project with Imperas DB. The new core is a more challenging and difficult development, but I expect Imperas DB technology to deliver both high performance and high quality.
Thank you, Adachi-san. So this is just a block diagram of the NSI-Tex IP. There's more information on their website, certainly. And he was referring to a deal that they announced with Renesas just last week. So Imperas and RISC-V DV. As I mentioned, 5 years ago, we saw this transition from academic exercise to industrial community. We've been working on models since 2016, working on compliance within the community, things that benefit the whole community since 2017, working with customers on RISC-V DV since 2018. We've been evolving different levels of DV. And today, earlier today, we announced Imperas DV, the solutions for RISC-V processor DV. So please come by our booth, and we can explain more about that. But going back to the original title here, the risk in RISC-V can be reduced to risk by deploying a well-thought-out verification methodology, including production-proven tools and reference models. Thank you very much.